Alright, so we're going to look at lesson 6.1a, and it's just kind of a review of the properties of exponents that you would have had in Algebra 1. So we've got some examples here. You have your list of properties. The first one is a to the 0 is equal to 1, and that means if I have any base and an exponent of 0 on it, that's going to be equal to 1. So an example may be that I have 3 to the 0 power. That's equal to 1. Or maybe I have x to the 0 power. That would also be equal to 1. All right, the next one is the quotient property of exponents. And that's a to the m over a to the n. And when you have a quotient with like bases, you're going to take the difference of those exponents. So a to the m minus n. And an example would be so for the second one, when you have a quotient property of exponents, a to the m over a to the n, you subtract the exponents. And so that would look like, if I were giving an example, maybe x to the 5th over x to the 2nd would be x to the 5 minus 2, which is x to the 3rd. You just subtract those exponents. Number 3 is the reciprocal or negative exponent, and that's if I have some base to the negative 1 power. That just means to take that base and it now becomes the reciprocal of that. An example would be if I have 5 to the negative 1st power, that would be 1/5 because I took the reciprocal. Number 4 is the power of a product. So I'm going to take some product, a times b to the n. When I take the power of a product, each of those factors inside the parentheses will get an exponent. So I have a to the n and b to the n. So an example may be if I have 2x to the 3rd. So the 2 is going to be taken to the 3rd power, and the x is going to be taken to the 3rd power, and so that's going to simplify to 8x to the 3rd. For number 5, that's a power of a power. So I have an exponent and then I have yet another exponent on there. So let's say I have a to the m and then to the n power. When you have a power to a power, you're going to multiply the exponents. So an example would be if I have x to the 4th to the 3rd power. That's going to be x to the 4 times 3, which is x to the 12th. On number 6, you've got the product property. That's similar to the quotient property of exponents, except we're multiplying. So if I have a to the m times a to the n, notice we have like bases, both a's are the same, then I'm going to add the exponents. So that's a to the m plus n. So it's the opposite of what we did in division. When you have division, you subtract the exponents. When you have multiplication, you add the exponents. And then an example would be x to the third times x to the second would be x to the 3 plus 2, which is x to the 5th. And then our last one is the power of a quotient. And so that's where we have some quotient. You have some quotient a over b to the n. And so each, the numerator and the denominator of the quotient would get an exponent of n. So a to the n over b to the n. An example of that would be if I have x squared over 3, and I want to take that to the third power. So I would take x squared to the third power, and I would take 3 to the third power. Now, x squared to the third power, that's an example of the power of a power, and when you have that, you're going to multiply the exponents, so that's going to end up being x to the 6th, and then 3 to the third power is 27. So that would be an answer for that one. Okay, on the second page it says simplify and write each expression using only positive exponents. So at the end we only want positive exponents. You'll see that we have some negatives. We're going to leave any negatives in there to begin with, and then we'll take care of those negatives at the very end of the problem. So I have, for A, I have 5a to the third times negative 3a to the negative 4th. That's really a bunch of products together. 5a to the third is a product, so that's 5 times a to the third. And then you also have negative 3 times a to the negative 4th. So that's going to be another So I'm going to multiply my numbers together. 5 times negative 3 is negative 15. And then I have the a's there that have like bases. I'm going to put those together. When you multiply like bases, you add the exponents. So that's going to be a to the 3 plus negative 4, which is negative 1. And you can see that we have a negative exponent there on the a. So we have to go back to our properties and look and see what that means. That means that we're going to take the reciprocal of a. So that's equal to negative 15 then times 1 over a. And that product is negative 15 over a. So there's our answer to a. Okay. Then for B, again we have a negative 4, x to the negative third, y to the 5th, and then all of that's to the second power. That's going to be the power of a product. And anytime we have a power of a product, we want to put an exponent on each factor inside. So I'm going to have a negative 4, that whole number there, to the second. I'm going to have my x to the negative third to the second, and my y to the 5th to the second. negative 4 squared is positive 16. And then for each one of the remaining terms, or factors, it's the power of a power. So when you have two exponents, you multiply the exponents together. So that'll give me x to the negative 6 and y to the 10th. And you're going to, you see that you do have a negative there, exponent. When you have a negative exponent, that means that you're going to use the reciprocal. So I'm going to rewrite that as 16 times 1 over x times y to the 10th. And so that's going to be 16 times 1 times y to the 10th over x. And that's going to be my answer for B. Okay, I'm going to go back and do C. If you just rewind this video, you'll be able to see the work from problem A and B. If I go back to C, I see that I have a quotient there, so a fraction. When I have a fraction, I'm going to kind of divide that up into pieces with like bases. So I have a 4, I have A, B to the 6th, C to the 3rd, and in the denominator I have A to the 5th, B, and C to the 3rd. You can break that up into one fraction with your coefficient, which is your number, so that's just a 4. There's nothing in the denominator. And then I've got my A's, so that's A to the 5th, or I'm sorry, A over A to the 5th. Try that again. Times then B to the 6th over B, and C to the 3rd over C to the 3rd. And I'm going to simplify all of that. So that gives me 4. That's A to the 1st. So when you have a quotient, or a quotient with powers, you're going to subtract the exponents. So it would be 1 minus 5. So A to the 1 minus 5 would be negative 4. The B's, again, that's B to the 1st, so 6 minus 1 is 5. You're going to subtract the exponents. And for the C, 3 minus 3 is 0. So I still have the 4. Anything to the negative is the reciprocal. So I'm going to say 1 over A to the 4th. Notice that the 4 is still the same. The negative's gone when I take the reciprocal, though. And then B to the 5th and C to the 0, anything to the 0 power is 1. So when I multiply that all out, I have 4 times 1 times B to the 5th is 4B to the 5th over A to the 4th. And that's my solution. Okay, you have some exercises at the end. Exercises at the end of the problem to do.